Friends, hello everyone. I'm glad to announce that we are halfway through our course. Congratulations on that. In this lesson, we will learn how to send the Toncoin cryptocurrency to the smart contract balance. We will learn how to withdraw Toncoin from our smart contract in several ways. And the second part of the lesson, we will learn how to make our smart contract create other smart contracts. We will talk about this more in detail later. For now, I want to tell you a bit about the theory of smart contracts in Ton are made of. Smart contracts in Ton have a very cool future, or rather their addresses have a very cool future. They are completely deterministic, that is predictable. We can calculate them. In other words, we can calculate the address of a smart contract that has not yet been deployed to the blockchain, which doesn't yet exist. We can know in advance what its address will be, and we can calculate the address using two components: code of the smart contract and the initial state, or initial data, initial storage that was written at the moment of the contract deployment. Having the contract data and having its code, we can combine it together to calculate the address of the smart contract. This is actually a very cool technical feature of the Ton blockchain, which we will look at today as part of this lesson. Okay, cool, let's start. Before we start sending Ton coins to our contract, let's first take a look at how a message is sent from the smart contract itself. We have done this in the previous lesson, but now we will go into it in more detail. Let's do this receive, and to send a message, we use the send method, and then we have the SendParameters object. And now let's talk about which fields are necessary and which are not. Of course, field 2 is necessary here. Field 2 needs to specify the address of the contract. Suppose we specify the sender here. Next, the necessary field is the value field. This is the amount of Ton coins we want to send. Let's write 0 for now. The next important field is mode, which is how we want our message to be sent, and by default I'll write set ignores here. Send ignore is a received word that represents an H-bit operator, and when we set such a send mode, all we are saying here is that even if an error occurs during the sending of this message, our code will not stop. Our code will continue to work and there will no reject transaction. I will tell a few more modes later on how you can send a transaction, but for now let's move on to the next fields. The next field is bounce, and by default it sets to true. Don't confuse this with the bounce that we discussed in the previous lesson when we tell our smart contract that we are ready to receive messages with the bounce flag. Messages that had errors and bounced back. By default, when sending a transaction, the bounce flag is set to true. This indicates that we expect that if the message we are currently sending to the contract is erroneous, meaning there is an error on the other contract, this message will bounce back to us and we will handle it. If we set it to false, then nothing would bounce back. No message would be returned. So let's leave it by default. The next field we are familiar with is the body field. Here we put the body of our message, and the body of the message must always be in cell format in Ton, even when we work with text. If we want to send a textual message in tag, we must use the asComment method at the end. This method converts our string into a cell. Next, we have the init and code fields. We will talk about them when our contract is deploying other contracts. This is what I was talking about code and initial state. For now, we will remove them from here. And actually, these are all the fields we need to send messages. Here I also want to tell you that you can express such a message in a simpler way, which is self-reply, and then the body of the message. But this is only if you want to reply to our sender. to the one who sends this message. If you want to send a message to a different address, then this method won't be suitable. It's also important to know that each message has a context. It carries additional information. The context can be called as follows, and the context stores the following fields: bounced, sender, value, which is amount of cryptocurrency Toncoin being transmitted in this message. The context also stores other data in raw format as bytecode in the form of a slice, which we won't consider now. Okay, we now delete all this and leave our receive method empty. This means that our smart contract will be able to receive the Toncoin cryptocurrency on its balance. Also, we will provide in advance that only the creator of this smart contract, only the owner, will be able to withdraw these funds. Let's write the first method that will allow you to withdraw all the money that is on this smart contract. First, we created a check to verify that the sender is the owner. If the condition is true, then we proceed. If the condition is false, then our message gets rejected. Let's start filling in the message to send. We write SendParameters, and here's an interesting part for value. I'll put a value for 0, but in the mode field I'll write a certain mode. Here, in the message sending mode, I have indicated that besides the fact that the message will ignore errors, I'm also sending the all remaining balance. I have indicated that besides the fact that the message will ignore errors, I'm also sending the all remaining balance that I have on the smart contract to the address specified in the field 2. This means that in the value field we can write a value of 0, because we are anyway sending all amount. Okay, let's check this. Let's start writing a test parallel to our contract. First, let's compile the contract, a semicolon. Of course, we should specify the self-owner here. The contract has been compiled. Let's, as usual, I'll take out the deployer app, and at the before each, I will now send some amount of Toncoin to our smart contract. After our contract has been compiled, I write send_ton send. Naturally, I do this from my deployer. For value, let's say I'll send a larger amount. Let's send 500 Toncoins. As for the message, my message doesn't accept anything as it's an empty receive, so I specify null here. Great, and in the should_deploy method, I'll expect that it should deploy and receive ton. Oh yes, and of course, in order to get our balance, we need to write a get method for this in our smart contract. Let's do this now. We will return the balance in the form of a string. For this, we have a special default method, myBalance, and this value we convert into a human readable form. Now we have such a method. Let's see what it will equal. Yes, that's correct. We see that there really is, well, a bit was spent on commissions, but 500 Toncoins were transparent. Okay, and now our task is to verify that our withdrawal will work correctly. Let's do this. Let's start by checking that our require works correctly, making sure that we can only withdraw money from our deployer's wallet. For this, I'll create a new sender and call it not deployer but user. Now from the user's wallet, I'll try to send a message, withdraw all. I'm still sending a small value of Toncoin here so that there is money to pay the commission. And I specify the message as withdraw all. But before doing this, let's first get the balance of our user before sending the message, and then do this after. We can already delete it here. We run our test and we see that the balance of our user has not changed much. That is, he paid the gas fees, but no more Toncoin came to him. To make sure of this, let's use the from nano method here. And here it's more clearly visible that there indeed was a million Toncoin and almost the same amount remains. Let's remove these console logs to clean our test. And we will add a check here that our before balance will be greater than or equal to the after balance. Let's check that this works. Great. And now, in a sense, we will do the same logic, but the balance of the deployer or owner of our smart contract. Here I changed the naming a bit, and now I will get the balance before deployer. I'll duplicate this part of the code and let's look at the console. Yes, here we already see that before we sent our send transaction, we had 999,499 Toncoin. After we sent, we returned back the money that we took from our contract. That is, in the beginning we sent our Toncoin to the contract and then we took them all back. Great. Let's cover this into a test as well. So we have made the first withdrawal of our smart contract balance, and actually this withdrawal is not the best method. Because as we withdraw all the money from our smart contract and leave a zero balance, it means that the smart contract will not have money to pay rent for storage in the blockchain. And if the contract doesn't have these funds, in the end the smart contract will be deleted. And we don't want this. We want the contract to have a little money left so that it can continue to pay for its existence. For this we will write the next method. We will call it receive withdraw save. Withdraw save can also only be called by owner, and we will pass the following parameters to it. We will also have sender. Let's also put bounce true here. And the value we'll already not put as 0. We'll calculate the amount we want to send ourselves, and we will calculate it as follows. We will take the myBalance method, which will return all the money that is on the smart contract, subtract from it the context value. That is, we do not take into account the money that comes to us in the message withdraw save that we will be sending from our wallet, and we will also subtract from the minimum of Ton value needed for our contract. We will define it ourselves. Let's create this variable ourselves. Actually, it will not be a variable for us, it will be a constant for us. We'll call it min Ton for storage, and it will be 0.01 Toncoin. This amount should be enough to store about 1 kilobyte of data for 2.5 years. Okay, and we will also subtract this amount from our send value. But what should we specify in the mode field in this case? What mode of this message? How do we want to send it? Naturally, we will also have send ignore, but in addition to this, we also want the money that we send in the process of the message. That is, this 0.2 Toncoins will first be used to pay the commissions for these actions, but something will be left from this and we will send this something back to our sender. For this we will indicate the following value here. It's send remaining value. Let's try to build this as usual. Now we'll fix the errors. I always forget the semicolon. The build was successful, and now let's quickly test this in the following way. We'll completely copy this test. It'll be identical, I'll rename it to save, and the only thing I will check here additionally is that the balance of my smart contract will not be 0. Yes, of course we should also rename the body of our message here. It will now be withdraw save. Let's run the test again, and we see that the balance of the contract remained. Only I thought that probably as a string it's not very convenient to return. I will return it in integer format, so that there is a possibility to write a convenient test, in which I'll say that I expect the balance of my contract to be greater than 0. I will build again and run the test again. Okay, and the last method we will write here is the method that allows to withdraw the specific amount from the contract. For this we will need a message. I'm creating a new receive type of withdrawal. As we can see, friends, our owner checking functionality is constantly duplicated, so we can a little improve, optimize this, and write a function that will do this in one place. I'll write here a function only owner. I'll move this line of code here, and now I only need to write in this way. So, the withdrawal of some specific amount will be more interesting here, because we need to consider that when withdrawing the sum, we just have this money, and also consider that we also left a minimal ton for storage on the contract. For this I calculate the amount, which will be withdrawn in the following way. Here I am saying that my amount will be one of two values, either message amount or this expression, and whichever of them will be the minimum will be go to my amount. Why am I doing this? I did this because in the case if the balance of the current smart contract minus the amount we are sending to pay the commission minus the minimum value for storage will be less than the total amount we want to withdraw in the end, then we will not allow this amount to be withdrawn. We will withdraw as much as we can afford. That is, in the case if we have half a ton coin on our contract and we want to withdraw 1 ton coin, then we will end up withdrawing 0.49 ton coin. And also in the case if we don't have any balance for sending at the end, we will also check this here. We start to form a message, SendParameters, field, sender, bounce is also true. The value we pass is the amount we calculated, and as mode we will pass the same operators that we had above. Okay, let's build it. And I, as usual, forgot a semicolon. Now we will correct. Our contract was built, and we will write the third test. It also will be very similar. We will name it should withdraw message. The message we will declare right here. It will be of type withdraw. And as amount, let's do, for example, 100 ton coins, or even no, 150 ton coins. Okay, and now we put this message. The only test we will write here is that the balance of our deployer after he sent message to withdraw money will be 150 ton coins more than it was before. For this here we add our additional ton coins, but not quite more. It will be to be greater or equal. In fact, these values should be almost equal, but since there will be payment for the commission, there will be a slight difference. But let's look also in the console. So I did something wrong now. Let's look. Now I convert all this into readable code. So I see that indeed everything is correct. That is, in principle these values are equal. The balance after equals 999,000 and 649 ton coins. And the balance before plus 150 ton coins is exactly the same. The only difference is in small values. Balance before is slightly more because the commission is paid after all actions. Okay, let's fix this. Delete the console log and restart. Though in our test for some reason I see such a big difference, so let's now figure it out and then I will tell you what was the matter. Everything is clear, I start to get confused. The balance after will be the ton coins that we will withdraw, and the balance before is without these ton coins. It turns out that now we want to compare the balance before plus 150 ton coins. We will be a little more or the same than the balance after. Let's run the test again. Now everything has passed. So well, we sent in ton coin to the contract balance and back we managed. We looked at different modes of sending messages. There are other modes, but within the framework of this lesson, I wanted to show you only these two main ones to understand the principle. Now we will create a smart contract that will create another such smart contract. Close the previous code now. First of all, for a smart contract to be able to create another smart contract, it must know the address of the smart contract, which doesn't exist yet. And as I said at the beginning, the address of smart contract consists of the original data in this contract and a code. Let's now write a small code of our smart contract, which will have an ID and it returns its address. As you remember, my address is a default method in Tact that returns the address of the contract. We specified the getter that we can use outside the blockchain, and let's write exactly the same contract, only item 2. And if we try to deploy all contracts now, the addresses will be completely identical because they have the same smart contract code and original storage. All we need to do to make these addresses different is to change the ID here. And also for clarity, we will write here an additional method that returns the address not only of this contract, but also for another smart contract. For this, first we must get the state init. We'll create a variable init, which will be of type state init, and we can get it using the operator init_of. And then I indicate the contract state init, which we want to get. Our contract is called item2. In my case, my init doesn't take any arguments, so I don't pass anything. Okay, and then to calculate the address of our smart contract, there is already a default method. It's called contract address, to which I pass init. Okay. I'll add the same method for our second contract, only it will return the address of the first one. Let's look at how this will look in the test at the moment. Here I made a typo. Okay. Let's prepare our tests a little bit. Make item 2. Here I always initialize a contract item 2, and in before each I deploy these two contracts immediately. Okay, let's check that the deploy was successful. I forgot to delete the extra console logs. Let's clean it up now. But the deploy, as we saw, was successful, so we don't need more console logs. Okay, let's write a new test here. We'll call it should return addresses. And let's first get the addresses of our smart contracts using the function getMyAddress of both contracts. And then we will call getOtherAddress and compare whether it is equal to what we expect. Here I will immediately extract otherAddress1, which I will return from this contract. And similarly otherAddress2, which I will extract from the first smart contract. And let's try to compare them with console logs. I call the test and expect that these addresses should be equal. We look at second address and other address too. They are equal and the same with the first one. Excellent, super. Now I will convert these console logs to the test so that we can delete them and we will continue. Great. And now I think we are ready to write a smart contract that will deploy other smart contracts. We will name it item2, or let's just copy this code. It will consist exactly of the same methods that already exist. The only difference here is the ID. We will pass it to him through the constructor method. The otherAddress method will also accept the ID in order to calculate the addresses of smart contracts that do not exist yet. In the future it will create a contract that is exactly the same as itself. So it will calculate another address from itself. And as an argument in this case we need to pass him other ID. Okay, let's write the method for the deploy. For this we will need a message. Let's name it deploy contract. Here we will have only one field, this is ID. And now we write receive deploy contract type method. First we also take his initial state. Then here we calculate the address of this smart contract and form our message. SendParameters 2 is our local variable address. As a value we will specify the value 0 here. And as we remember, we have the opportunity to specify the mode of our message, that we will also send all incoming money that is sent as part of the deploy contract message. That is, when we'll be sending messages from our deployer, we'll be transferring some amount of Toncoins, and all these Toncoins will go further. This will be used to deploy our contract, and the user will pay commission for this. And for this I do the following mode. And here we'll indicate the field that I talked about at the beginning. This is the code field. And the code of our contract is stored in the init variable. We can extract it in this way. And then the initial data that will be written in this contract. They are also already stored in our init variable. Okay, and now don't forget that our item also inherits from the deployable, which means that the deployment we must specify the deploy message. We do it in the following way. Then I remind you that the only field that is in the deploy message is the query ID. Here we pass 0, and also, as I said earlier, any messages, textual or such a format, must be passed in the cell representation. When it's text, we use the asComment method. When we have a message, we use the toCell method. And our smart contract is ready. Let's try to build it. Excellent, it works at first try. And now let's check that it also works in the test. Let's write a new test here. I name it should deploy new contract. And before deploying a new contract, let's check that our logic works correctly. That we can calculate the address of a smart contract that doesn't exist yet. I'll create a variable not exist address. Yes, we also have not created a contract item 3 yet. Let me add it now. As ID I will have 1 here, and also duplicate the deploy code. Okay, we continue. Item 3 get other address, and let's see, for example, what the contract with ID 14 will look like. Let's check it in the console. Okay, we got the address. Super. Now we can really deploy this contract and make sure that the addresses will match. For this I call item 3 send. Let me not put the deployer out every time, I just created it locally in this test, and we'll continue to fill in our message. As well, we will also pass 0 to. Also we choose the deploy contract message, and as ID we pass 14 in the format of begin. Okay, then we'll fully initialize this contract, create a variable new item, and just like the others, open it in our virtual blockchain. The first thing I'll do here is to get its address, compare it in the console, and also let's add a getter here so that we can read the ID, build it and get it here. And more, we can be sure that our contract has deployed because we call it storage. Got the ID and got the correct value. And that's all for now. As usual, thank you for your attention, friends. In the next lesson we will take a closer look at the syntax of the language tag, take a closer look at what types of data it has. So see you soon in the next lesson. Bye bye.